first look at y equals sine x. Now, because we use the circle to define y equals sine x or sine x, what you've got here is a wave. Imagine taking your circle, and as you go around, you kind of stretch it out, so you have this wave. And because sine x represents the vertical height of your circle at certain points, as you know, the distance between the x-axis and the circle itself vertically, you're going to get a certain wave that starts at 0 and goes up to 1 and then back down to 0 and then down to -1, and it continues in that manner, okay? Now, one period, that means one complete cycle that you go through has a distance of 2 pi or a length of 2 pi. So you start at 0 and you go up and down and back to 0. That's one complete cycle. And then you repeat for the next one. So that's called a period. And it also has a certain height of 1. The distance between the x-axis and the highest point is 1. That's called the amplitude, okay? So we have the amplitude, which is basically the height from the x-axis to the highest point, and then we have the cycle, the distance, which is the horizontal distance of how long the cycle lasts, and that's a period. So it's 2 pi, right? For sine, you'll see that the x value for that point is 2 pi. Okay, so that's the period. And then we can shift this around, and that would be called a phase shift, but we'll talk about that in a minute. So here's our original function. Now, can everybody see okay? I just want to make sure that you all are able to see. If you can't see, let me know, okay? So the next function that I would like to do is y, it's a variation of this, y equals 2 times sine x, okay? Look at what happens to the function. When you multiply your sine function by 2, it increases your amplitude. So now instead of 1, our amplitude is 2. And what do I mean by amplitude? That means how far does this wave stretch from the x-axis? What's this distance from the x-axis to the highest point? This height is 2. See, you can see it on the y-axis, that top hill, if you will, or whatever, the top of the wave is the height of 2. Okay? And then when it dips down, it's in a valley, and the depth is 2. So that's called the amplitude. The amplitude is a distance, so it's always positive. Even if I put a negative sign in front. Now watch what happens when I put a negative sign in front of the 2. I'm going to get rid of my sine graph here so it's not too cluttered. And so I have y equals 2 sine x. Now I'm going to do y equals minus 2 sine x. See how it flips the graph over the x-axis? So what was above is now below, and what was below is now above. So whenever you multiply by a negative like that out in front of your function, it's going to flip your whole entire graph over the x-axis, and you're going to have like a reflection there, if you will. Okay, that's called reflecting. All right. Now I should let you know that I'm remembering now what it was that my students couldn't see when I taught this on Monday. I wanted to go into the homework and show them how to use the graphing utility, and that was not showing up through Zoom. It was a pop-up window and they could not see it. So I'm not even going to try to do that. I'm just going to use Desmos here. So when you're doing the homework, there's a graphing utility embedded in the assignment. And when you click on that, it'll help you graph the function. You're going to have 2 choices. So let me just show you what it's going to look like when you pull that up. So you've got your sine x function, and it's just going to show you a piece, and I'm going to try and restrict the domain here so you can see what I'm talking about. Hold on. Just give me a moment. I think I go like this. And then I type in 0 is less than or equal to x, which is less than or equal to 2 pi. There we go. All right. So as you see here, when you pull up that graphing utility in your homework, it's going to have a little square or a little box with a picture of a wave like this. Okay? That means that you are going to, if you are trying to graph a sine function, you are going to click on the box that has this picture in it, showing you that it's a sine function. And then your sine function will appear on the screen. But before it does that, now listen carefully because I can't show you. I wish I could show you, but I can't. Before it does that, you're going to have to position your cursor right at the origin, click it. So first you go and click the box that has this picture in it. Then you go to the graph and point at the origin where you want to center it and click one click, and it will all of a sudden appear there on the graph. Okay? Then a little box will pop up, and in that box you specify the amplitude that you want. You specify whether you want to reflect it across the x-axis or the y-axis. You just do all your specifications. So you don't have to physically graph it. You just have to put your specifications in the box. All right? So that's how that works. And I wish I could show you, but like I said, my class yesterday could not see it. So we couldn't get it to work. So I'm not even going to try. All right, now watch what happens when I change this function to cosine, and instead of going from 0 to 2 pi, oh no, I want it from 0 to 2 pi, yeah. I'm just going to put cosine in here now, okay? Look at the shape of the graph. It's still a wave, but instead of starting at 0 and then going up and then back to 0, it starts at 1, dips down to -1, and then goes back up to 1. So it's shifted off from the sine function. So when you're graphing in your homework, you're going to select the shape that looks like this for cosine and then position it on your graph if you want to graph a cosine function. So it depends on what you're graphing, right? So there are two options. You're going to either pick this shape graph for sine, okay? And you'll see what I mean when you see the little boxes to the right. Or if you're graphing cosine, you're going to pick this shape, okay? And that's in section 5.5 homework. All right, now back to the discussion of how we graph these. Okay, so here is the cosine function. If I want to have an amplitude of, let's say I want -3 cosine x, okay? Now, you see that negative in front? What it does is it takes, this is a valley, right? It becomes now a peak when I multiply by negative. And furthermore, since I'm multiplying by -3, it stretches that, so the height of the peak is up to 3 instead of 1, okay? Well, the amplitude is still 3 because remember, the amplitude is the distance from the x-axis to the highest point. So the amplitude, even though I have a negative in front here, the amplitude is still 3 for this function, okay? Now, what happens if I put a constant in front of my x? So let me get rid of this function here. And, whoops, I went too far. Y equals cosine. I'm going to, instead of x, I'm going to put 2x. Well, let's do both. Here's x, and here's y equals cosine 2x. So the only difference between my two functions is this 2. That 2 multiplied in front of the x, what it does is it compresses the function horizontally. So basically, when you multiply by 2, it basically means you're going through your cycle twice as fast. So instead of going from 1 over 2 pi, now I'm going to go through a full cycle at pi. and then I go through another. So I go through 2 cycles over the course of one period, a normal period, okay? A normal for cosine. So cosine, the period is 2 pi, but if I have cosine of 2x, the period is pi. All right? Well, let me go back to the notes for a second now. And let's talk about this. All right? So the pattern that we're looking at is y equals a sine bx plus c plus d. All right? What A, B, C, and D are constants, and they all have meaning, okay? The A is the amplitude, and actually the absolute value of A, I should say, is the amplitude. I talked about that a little bit. Your period for sine is 2 pi, but when you multiply by a constant 2 in front of the x like we did earlier, we have to divide. It shortened my period because I went through 2 cycles in the same amount of a period as regular sine. I don't know, I'm not saying it very well, but so in other words, the period is 2 pi over b. That is called the period. And then I haven't talked about this yet, but the phase shift is minus c over b. And I will talk about that in a minute. And finally, d is the vertical shift. So d, if so it's up if d is greater than 0, and it's down if d is less than 0. Okay? So basically, this is what you want to focus on for section 5.5. You want to focus on A, B, C, and D and understanding amplitude, period, phase shift, and vertical shift. Not so much vertical shift. I think the last 2 problems in the homework deal with the vertical shift, but your focus is going to be mostly on the first 3, amplitude, period, and phase shift. All right? So let's look at some examples, okay? I should probably let you finish writing on that. Just give you a little bit more time to do that. And so some of the homework problems, they'll give you a function and they'll ask you questions about it. So for example, if y equals 6 sine x, okay? The amplitude is 6, so A equals 6, and so therefore the absolute value of A equals 6, and so that means that the amplitude is 6. All right. Now, the period for this one is 2 pi, okay, since our b is equal to 1. Okay, so b is this constant in front of the x. Well, there's nothing there, so it's assumed to be 1. We haven't changed the period because we haven't multiplied a constant there. And the phase shift is 0. There is no phase shift. In other words, no shift. Since c equals 0. Okay, so this is a pretty simple problem. Really, all that they're going to ask you in these type of problems is what is the amplitude, and then graph it. All right, if you need to use Desmos to help graph it, really honestly, the graphing part is fairly easy. It's just using the graphing utility in your homework can be frustrating, but you'll figure it out, okay? So the first 3 questions in your homework just ask you what is the amplitude and then graph it. And they want you to graph it next to sine x. So you're actually going to put 2 functions on the graph, kind of like I did in Desmos there. All right, now for the next problem, y equals sine 3x. Okay, the amplitude is 1 because the absolute value of A is 1. So the amplitude is 1. And that's because this constant in front of the sine is not listed there. It's assumed to be 1. The period, remember, is 2 pi divided by b. Well, in this example, b is, I want to use a different color here. B is 3. Okay, that's your b. So 2 pi over 3 is the period. There, again, there is no phase shift because we have not added or subtracted any constant here, okay? All right, so any questions on that so far? All right. Now, A equals 1, so the amplitude is 1. B equals 1, so the period is 2 pi. And now C is negative pi over 2, okay? So our phase shift is pi over 2. So the phase shift is the opposite of your C value, right? Alrighty, let me just graph this in Desmos real quick so you can kind of see what the graph looks like when you have a phase shift. All right, so remember this function here is x minus pi over 2 inside the sine. I'm going to share my screen, going back to Desmos. And let me get rid of this. So my basic function is y equals sine x. And then along with that, I'm going to graph y equals sine of x minus pi over 2. So pi divided by 2. Okay? And you can kind of see what happens there. So the green function is the regular basic sine function. Now, when I subtract pi over 2, this point here gets moved over here. So now, instead of the function being 0 at 0, it's now 0 at pi over 2. And the original function at pi over 2 was 1. Well, now, if I go a distance of pi over 2 over, the blue function is at pi is equal to 1. So everything gets shifted to the right by pi over 2 units. So that's a horizontal shift, so I'm looking at the x-axis to see. So going from this point here at 0 over to this point, you can see that the x value changes from 0 to pi over 2. And that's the phase shift. We're shifting our graph. And notice it's a horizontal movement because this constant that's being subtracted is inside the function as opposed to outside the function. Now let's watch what happens. I'm going to get rid of this now, or I'm going to change it a little bit. What if I subtract pi over 2 outside the function? Okay, so there's my function. Now I'm going to subtract pi over 2 on the outside. You'll see what happens is it shifts the whole thing down. All right, and remember pi is about 3.14, so if you divide that by 2, that's going to be 1.7. Let me think, am I thinking that right? 1.5, 3.14, so 1.57. So you can see right there is about from 0 to -2 is this distance, and this right here is about, well, it's negative pi over 2, which is about negative 1.57, okay? All righty? So you can see it makes a big difference if your constant that you're subtracting is outside the function or inside the function, right? Go back inside the function and pi divided by 2, and there you have it, okay? So this is a phase shift, whereas when it's outside, it's called a vertical shift, okay? So play around with this Desmos and you'll learn how these constants affect our basic functions, our trig functions. And all of this discussion for, let me go back to the notes. All right, all of this discussion here applies for cosine as well. So let me go ahead and write that in there. You can have the same thing going on for cosine. Okay, tangent and cotangent are different functions. All right, let's see. I want to do another example. Any questions on this so far? All righty, let's see. So we need to describe what's going on here for this graph. So the amplitude and I think I'd like to use some different colors here to highlight this. So the amplitude is minus, well, actually, this is our A value, okay? And this is our B value. There's C. And finally, there's D. I hope you can see that. All right. So what can we say about the graph? Well, the amplitude is the absolute value of A, so that would be 5, okay? The period is, okay, first off, cosine has a period of 2 pi, so I know that's going to be 2 pi, but then I have to divide it by my B value, which in this case is 4. Okay, and so that is equal to pi over 2. That's my period. The phase shift, this is the horizontal shift, is negative C over B, which in this case is the opposite sign of C. C is negative pi, so the opposite sign is positive pi. And then I'm dividing by 4. So this is my phase shift right here. And finally, the vertical shift is up 1 unit. Okay, so those 4 properties help us understand the graph of our trig functions. In this case, it's cosine. All right. By the way, just to remind you, the period for each of our trig functions. Is 2 pi for sine, cosine, secant, and cosecant. Okay, those 4 trig functions have a period 2 pi, and it is pi for tangent and cotangent. Okay. I'm trying to think of what example this is that I did. Hold on. Example 4. All righty. Any questions on that? Feel free to type something in the chat box if you don't want to say something out loud. Okay, let's see. Notice that this constant in front is negative, but the amplitude is still just 5, because the amplitude is a distance, and distance is always positive. Why don't we go ahead and graph this function in Desmos? So this time we're working with cosine. Y equals cosine of x. And then our function that we're trying to graph, which is a variation of cosine, is minus 5 cosine of 4x minus pi. Let me see here. And is it plus 1? Yeah, plus 1. There we go. So everything was shifted up 1. So if I graph y equals 1, that purple line is kind of the midpoint between the top and bottom of your function. So there we go. So from the bottom to the top, this is the midpoint. So you can see everything is shifted up 1. The amplitude is 5, so the function would have gone up to 5, but because we added 1 at the end of the function, everything got moved up 1. And it would have come down to -5, but again, because everything got moved up, it comes now down to -4. So there's that vertical shift. But then, instead of taking a whole 2 pi to go through one cycle, it goes through 4 cycles. So it goes up, it goes down and back up, down and back up, down and back up, down and back up 4 times for the original function to go once. And that's because of the 4 times x in the problem. And then you have your phase shift, which is pi over 4. And this is a cosine function. And I've not really seen the phase shift very well, probably because it's so small. Let's see here. It's really hard to see. Maybe I should change my graph a little bit here, just so we can see it better. Let's take out the 5. And let's go ahead and take the negative out. And let's take out the 1. And just focus on the phase shift now. So now I'm going to zoom in here. So remember, originally we had flipped the graph, but this one is not flipped. So it starts at 1, but now because of the phase shift, instead of starting at 1, it's going to start over here at pi over 4. So you can see how it's been shifted. This high point is now shifted over to this high point. And you can see when I hover over that with my cursor, it shows me that the x value is pi over 4. So that is the phase shift. This point, this high point, has been shifted over pi over 4. And notice it's shifted in the positive direction because this is a minus sign. It's kind of opposite of what you think. If you subtract a constant, it's going to shift your whole graph in the positive direction. If you add a constant on the inside, it's going to shift it to the left. And that you should remember from when you learned this in algebra, translating functions. Adding on the outside shifts up, subtracting on the outside shifts down, but adding on the inside shifts it left, and subtracting on the inside shifts it right. So you might want to review those translation rules from algebra, but you don't really have to worry about it too much because I'm not going to have you actually graph anything for the test. And that's simply because I want you to focus. First of all, it's very hard, and you're not going to have a graphing utility, and not everybody has a graphing calculator. So I don't want the people who happen to have a graphing calculator or have an unfair advantage to those who don't have one, you know. So to keep it fair, I'm not going to have you graph anything on the test. So this is just for your homework purposes. You can use Desmos to graph it on your homework if you need help. And even your homework itself uses a graphing utility. So you don't actually have to graph anything yourself. But for the purpose of the test, what I want you to focus on is knowing how to find the amplitude, the period, the phase shift, and the vertical shift. Those are the things that you should know for the exam, at the midterm exam. Amplitude, period, phase shift, vertical shift. So you want to go back to these rules here that I showed you earlier. Know these rules. You're going to have to know them by heart, okay? The absolute value of A is the amplitude. 2 pi over B is the period for sine and cosine. And then minus C over B is the phase shift. And D is the vertical shift.